Section 1.8 today. Remember when we did section 1, we didn't do, or we skipped 1.8 because I said we're going to do it later when it fit more naturally. Well, this is later, and this is where it fits. So that's what we're going to be doing today. So we're going to start by just remembering some things from geometry. Yeah, so we want to remember our types of transformations from geometry. So one type was translations. We had reflections. And then we have dilations. So if you remember, for a translation, like if we have like some square, a translation is just basically like, oh, we're going to move it like 4 units over and 3 units down. So just like ends in a new spot, right? But the size of your square stays the same. The orientation of your square stays the same. It's just now in a new location. Everybody's okay with that? A reflection. So say we have like a triangle, right? It looks like this. And we reflect it across this line. When you do that, it's going to be a mirror image, right? So the location has changed. The orientation has possibly changed. Notice like here the vertex points left versus before the reflection is pointing to the right. Or the apex, I should say. But the size still stays the same, right? And then a dilation, that's like a shrinking or stretching. So if I had, again, my square and I dilate it, maybe it gets big, right? So there, the size is changing. The location of the vertices most likely change, but the orientation should stay the same, right? So those were the 3 of the major types of transformations you guys would have talked about in geometry. And remember, I can take any set of points, like the vertices of a square, and I can apply this transformation to those points to create a new figure, right? Everybody kind of remember doing that in geometry? I know it was a long time ago. But here's the deal. A function is really just a set of points, right? So we can take this same idea, these same types of transformations, and apply them to how we think about a function. So the vocabulary we use is we start by talking about a parent function. That's like the before. And usually when we talk about a parent function, we just say, okay, that's just some y equals f of x. And then we have some resultant function. That's like our after, where we've done some kind of transformation. And our resultant will always be like some version of the parent, right? The way we're going to change the resultant is with the formula given here. So we have this y equals a times f of 1 over c times x minus h plus k. And somehow this a, c, h, and k are going to perform those types of transformations we have above. So the translations and reflections and dilations will all be handled somehow by these coefficients a, c, h, and k. So what we'll start with is just talking about how I can tell from just the number, from what is the value of A, C, H, and K, what kind of transformation is occurring, right? What would it look like? So if C is negative, we get a reflection across the y-axis. And if C is positive, there's no reflection at all. And C can't equal 0. Why can't C be 0? Because it's in the denominator of a fraction is a great answer. Yep. Okay. So C is going to control reflections like left and right. Is everybody okay with that? So reflecting across the y-axis is like a left and right reflection. Everybody's okay? Well, C does something else. Hi. Thanks, dude. Luca, it's for you. Yes, absolute value of C greater than 1. So you're going to get a horizontal stretch. So think about like our square from before. If we horizontally stretch that, what are we going to end up with? Like a rectangle, right? Like a stretched out square. If we stretch it left and right, you'll end up with like a rectangle. So it kind of stretches it that direction. If the absolute value of C is less than 1, we're going to get a horizontal shrink. And if the absolute value of C is equal to 1, no dilation is happening. I guess I should say horizontal dilation. So let's take an example here. Absolute value of C is less than 1. Give me a value of C where that's going to be true, other than 0. Nope. Absolute value of -2 is +2, and that's greater than 1. Yeah, absolute value of C is less than 1. What? Negative 0.25 would be an example, right? So numbers that are between -1 and +1, oftentimes how will those end up being written? Fractions, like 1/2 or 2/3, 7/8, something like that is an example. All of those are examples of things where the C, absolute value of that C is less than 1. Okay, so again, you look at that and oftentimes you're like, other than 0, what is it? No. Not talking about 0, we're talking about numbers between -1 and +1. All right, third situation is our A's. So A also does 2 things. It's going to reflect across the x-axis if it's negative, and does no reflection if it's positive. So again, that's like an up and down reflection, right? If we're reflecting across the x-axis, that's like flipping things up and down. And then the same rules go for, same rules go for A as for C, except instead of horizontal, we're talking about verticals. So we've covered A's and C's now. We just need to talk about H's and K's. So we've talked about our dilations, right? We've talked about horizontal and vertical dilations. We've talked about reflections left and right, and then up and down. Across the y-axis, that's left and right. X-axis is up and down. The type of transformation we haven't talked yet about is the translation. That's actually controlled by the H and K's. So the H, when it's negative, it's going to shift your function left that many units. When it's positive, it's going to shift it right that many units. And when it's 0, it's not going to shift it anywhere. And then K is the same rules, except instead of left and right, it's up and down. Okay. So we have all this stuff here. Guess what Mr. Kulik's going to say about all this stuff? Yeah. This is all stuff that should be memorized, or at minimum, if you're a bad memorizer, this stuff would be prime note card stuff. Memorization was never my strength as a student, but at least not without context. Like, it was easy for me to remember when you built it and it made sense why it has to be that way. Never going to forget that. If it's just like a list of stuff to memorize, ooh, that was my weak spot. You know, excellent memory for stuff in context, terrible memory for arbitrary list. It is what it is. That's who I am. Let's look at some examples here. Okay, so our directions are going to be to describe the transformation. And then suppose our parent function is just y equals f of x. And our resultant function is y equals 3 times f of negative 2x minus 6 plus 5. So for us to do this, we want to start by figuring out the values for A, C, H, and K. Once we have those, it's just a matter of looking at our set of criteria we just wrote down and just figuring out which one they're, what each variable is doing or what each coefficient is doing, right? So to find A, C, H, and K, I want to start by rewriting my function that I'm given in this form. So that was the general form for the resultant function. So it should be fairly easy to see that A needs to be 3. And 5 needs to be K. But if I look at the middle, the minus 2x minus 6, that's not written as 1 over c times x minus h, right? So I'm going to need to do a little work on the inside for me to tease out where's the c and where's the h. Is everybody okay with that? Khalil? It is not 1. So what I want to start by doing is notice that this piece looks like it's been factored, right? I'm going to do the same thing here. What can I take out of minus 2x minus 6? A negative 2. Everybody agree with that? So that's going to give me negative 2, and then I'll have parenthesis x plus 3. But I still have a little bit of an issue here, right? I need to write negative 2 as 1 over c. I need to write this plus 3 as a minus h. So how can I rewrite negative 2 as 1 over something? Well, 1 over is the reciprocal, right? What's the reciprocal of negative 2? Negative 1/2. So I'm going to write negative 2 as 1 over negative 1/2. Right? Because if I do the reciprocal of a reciprocal, that's like doing nothing at all. Everybody's okay with that? Okay. And then I need to write plus 3 as minus something. Well, I remember plus is the same thing as minusing a negative. And now I have everything I want, right? K is 5. 3 was A. But now I can see that C is negative 1/2. And H is negative 3. So far, so good. That's the hardest part. That skill that we just did is a core skill to almost everything that we're going to be doing in Chapter 3. If you're not able to look at a function and peel off those values for A, C, H, and K, it's going to be a very long chapter for you. So this skill that we just went through, really important skill. Everything that we're going to be doing in Chapter 3 is going to be built around the assumption that we're able to effectively pull those values off. Yes? That's a parenthesis minus 3. No, that's just supposed to be a parenthesis. It's just my terrible, messy penmanship. You get that, though, right? You're not king penmanship over there yourself, so. I'm just teasing. Nobody is, right? All right, so we just go through the criteria here. So, well, I see that my C, which is equal to negative 1/2, is less than 0. So I know I have a reflection on the y-axis. The absolute value of my C is 1/2, which is less than 1. So we're going to have a horizontal shrink by a factor of 1/2. My A is 3, which is greater than 0. So I have no reflection from the A. The absolute value of A is 3, which is greater than 1. So I'm going to have a vertical stretch by a factor of 3. My H is negative 3, which is less than 0. So I'm going to be shifting left 3 units. It's supposed to be a 6. And because my K is 5, which is greater than 0, that's going to be shifting up 5 units. So that's my answer. Is everybody okay with, once I figured out the values for A, C, H, and K, how I wrote that stuff up? I just used that set of criteria that we described before that I told you was like, should memorize this or at least put it on your note card. The reason you're probably going to end up memorizing it accidentally is just you're going to do this, like 10 times on a worksheet and be like, okay, I got them memorized. Because I'm just sick of looking back and forth, back and forth, back and forth, because I did it 10 times or whatever. And it's like, okay, I got it. You know what I mean? Let's do a similar type problem. But this time our parent function is going to be y equals x cubed. And our resultant function is y equals 2x plus 1 cubed plus 4. So here, I can see that my f of x is x cubed, right? So the general form for my resultant, where the f is just going to be replaced by like cubed. So instead of having an f, really I just have the cubed. Is everybody okay with that? Okay. So if I look at what I have here then, again, right away, the A and the K are really easy to get. But the stuff in the middle, the C and H, I'm going to have to do a little work to get. Everybody's okay? So again, I need to write this x plus 1 as 1 over C times x minus H. Well, it should be easy to see the only thing in common between x and 1 is just 1, right? So all I can do is factor out a 1. Which doesn't really change anything. Everybody's okay with that? And then instead of plus 1, I need to write that as a minus h. So I'm just going to think about it as like minus a negative. So I see then my A and K we knew already. But my C is going to be 1. And my H is going to be negative 1. Khalil. Well, it's because this symbol is plus, but in the general form it has to be minus. So I'm going to take that plus and write it as minus a negative. so I can see what the H value really was. In short, the H value is kind of the opposite of what it looks like in the problem. If it looks negative, it's positive. If it looks positive, it's negative, which is easy to forget, but that's essentially what's happening. And I'm going to skip writing out the description now just because it's like kind of tedious and I don't think it's very hard. What I wanted to concentrate mostly was like doing another one of these examples where teasing out the A, C, H, and K, because that tends to be the difficult part for students. So far, so good? Okay, feel reasonably comfortable here? Okay. So let's do this then. New example. Oops. Oh, let's not do it that order. Let's do okay. So for each step here, we're going to try to figure out the A, C, H, and K. Write our general transformation, then like push that through the actual parent function that we're given. So if I look at step 1, if we shift right 3 units, which coefficient are we talking about? A, C, H, or K? H. Good. And what would the H be? 3. And then nothing else is happening on that particular step of our transformation, right? So if nothing is happening with K, since it's being added, K should be 0. And since nothing is happening with A or C, but those are being multiplied, those should be 1, right? If I look at my general function, A and C are being multiplied. So if they're not doing anything, they should be 1s, because when I multiply by 1, it doesn't do anything. H and K are being added, so when those don't do anything, they should be 0s, because when I add or subtract by 0, it doesn't do anything. Everybody's okay with that? All right. If I look at the next one, vertical stretch by a factor of 2, which coefficient are we talking about there? A, and it should be 2. So since C is not doing anything, it's 1. H doesn't do anything, it's 0. K doesn't do anything, that's 0. And then the last one, a reflection across the y-axis. Which coefficient are we talking about there? C. What should the value of C be there? Well, it has to be negative. It has to be less than 0, but it doesn't tell us there just has to be negative. Well, is there any stretching or shrinking going on this step? No. So the absolute value of C still needs to be 1, but I know that it has to be negative, so this should be the C is negative 1. Is everybody okay with that? And then the A doesn't do anything, so it's 1. H doesn't do anything, that's 0. K doesn't do anything, that's 0. So far, so good? All right, so I'm going to do this now in 3 steps. So my first step is going to be, I'm going to call G1. So that's like what's going to happen after I do that first transformation. So G1 is going to be A is 1 times F of 1 over C, which is 1, times X minus H is 3, plus K, which is 0. Or really, this is just F of X minus 3. Everybody's all right so far? And maybe I should have written this as F of X here. That'd make it a little bit easier notationally. Okay, so if I do F of X minus 3, what I'm going to do is I'm going to be plugging X minus 3 in everywhere there was an X, right? Just like when we talked about function composition last chapter, or 2 chapters ago, I guess it was. Is that okay? So I have X minus 3 squared minus 3 times X minus 3. How do I do X minus 3 squared? How do I simplify that? What do you guys think? How do I do X minus 3 squared? FOIL! It's not X squared plus 9. It's a FOIL problem, yeah. So I'll go ahead and do that in my head for you guys quickly. And then I'll just distribute the negative 3. So it gives me X squared minus 9X plus 18. So that's my G1. That's my first step of this transformation that we're doing. So my next step, G2, is going to be applied to G1. So on this step, A is 2, C is 1, H is 0, and then K is 0. So this is really just 2 times G1. So far, so good. And G1 is X squared minus 9X plus 18. So I just get 2X squared minus 18X plus 36. Then our last step, G3, is going to be applied to the previous function, which was G2. So in G3, A is 1, C is negative 1, H is 0, and K is 0. So this, oops, I didn't mean 3 there. That should be a 2, Mr. Kulik. Come on. Sorry about that. So if I do G2 of negative X, again, that means I'm going to be plugging negative X into G2 every place there was an X, right? So negative x squared is positive x squared. Negative 18 times negative x is 18x. And then the 36 is still the same. So this is my final answer there. So if I'm asked to do like several transformations in a row, you have to do them one at a time. And it's, again, you just figure out the A, C, H, and K from the statement. And then you plug those into the formula and you just kind of do the simplification to the, to the previous function. So basically what we did here is we went parent function to g1 of x, to g2 of x, to g3 of x. So transformation 1, 2, 3, and that was our final answer. Does that feel okay? I think sometimes like drawing a picture of kind of what it was that we just did symbolically helps. Where it's like we start at f of x, the parent function, we turned it into g1, then we turned g1 into g2, we turned g2 into g3, and that was our final answer. Okay with that idea? Let's talk about graphing now. Because that's really the place where we're going to use this the most in the next chapter. So here's the lovely part. So we have some points in our parent function that are x, y's. And we want to end up at points in our resulting function doing some kind of transformation, right? Well, to transform the points in our parent function to the resultant function, we can just do cx plus h and then ay plus k. Yes. You're welcome. Now this, super important. This is how we're going to be doing the graphing in chapter 3. If you don't memorize this, it's certainly something you'd want on your note card because that is our formula for how to transform our points, which will be super duper useful. We're going to use it all the time. If you don't end up memorizing it, surely you want to get it on the note card. So let's do an example here of what I mean. So let's say f of x is the points negative 2, 0, 0, negative 2, 2, 0, and 4, 4. And we want to graph then g of x, which is equal to 2 times f of x plus 3 minus 1. First step is going to be determine the values for a, c, h, and k. Who can tell me the value for A? 2 is correct. Who can tell me the value for C? It's positive 1, right? Because we can write this as, right? The value for H? Negative 3, excellent. Remember, the H is always kind of the opposite of what it looks like. And then the K is negative 1. So what I'll do then is I'm going to write my function map. So I'm going to have cx plus h, and then ay plus k. So I have x minus 3, comma, 2y minus 1. So now all I'm going to do to get my new points to plot is plug in to my function, or to my map here. So in place of x, I'm going to plug in negative 2. And then for y, I'm going to plug in 0. So I get negative 5, comma, negative 1. And I'm just going to kind of continue doing this. So 0 minus 3, 2 times negative 2 minus 1. It's negative 3, negative 5. And 2 minus 3, 2 times 0 minus 1. So negative 1, comma, negative 1. And the last one is 4 minus 3, 2 times 4 minus 1. So that's 1, comma, 7. So at that point, I can just graph those points, and I'm done. Everybody feel okay? So again, what's the key here? Is that map. We're just going to tease out the values for A, C, H, and K, use those to write our map, and then we just plug our values from the parent function in to get our new values, and we'd like draw and connect them, right? So if I were to draw this, 1, 2, 3, 4, 5, 1, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7. So negative 5, negative 1, it's like here. Negative 3, negative 5 is like down there. Negative 1 is like right there. And then 1, 7 is like there. So my function kind of looks like that. Everybody's okay? So in chapter 3, we're going to talk about graphing sine, cosine, and tangent functions. So we're going to do kind of the same process there. We're going to start by just learning about the parent versions, the simplest version of sine, cosine, and tangent, figuring out what those key points should be, and then to graph them, we're going to do the same kind of transformation mapping and then plot and connect things. So it'll be very much the same idea we saw right here. We're just going to have new functions with new key, like points to work from. What I'd like you guys to work on for the rest of class would be this worksheet 1 that's in the content library here. So the first page is just like I recopied in some of this stuff. So it says the first page says describe the transformations from the parent function. So I did an example here. I did the first one, figuring out the A, C, H, and K for you guys. I didn't write up the transformation, but I just, exactly like we did in the notes though, right? And then the next 2 pages are graphing ones. So for these graphing ones, the points from your parent function you're going to use are these 5 I've written on the side, -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. So again, you'll do these just like that last example. Yes, sir?
So the very first page is...
Just like me recapping some notes. Nothing for you to do on that page. So it's, what is there, 8 problems or something? Not too bad. Everybody feel all right?